Good morning and welcome to National Astronomy Week 2020 Mars Encounter. We're excited to bring to you today two Mars on Earth activities, which will tell us the difference between Mars and Earth and what the study of space brings to understanding our own planet. Hello, my name is Lucinda Offer and I am the chair of National Astronomy Week. Today, my co-host is Jackie Bell. Good morning, Jackie. Would you like to say hello?
Good morning. Hello, everyone. Thanks, Lucinda. As Lucinda said, my name's Jackie. I'm a senior teaching fellow in the Department of Computing at Imperial College London. And in my spare time, I'm also training to hopefully one day become the next British astronaut. So I'm super excited to hear from today's speakers as part of the celebrations for National Astronomy Week, especially since we'll be covering my second favorite planet, Mars.
Woohoo! Excellent. Oh, it's so excited to have you here with us, Jackie. Thank you so much. Just a little bit of housekeeping before I pass it back to Jackie to introduce our first speaker. If you have any questions, we are going to have a Q&A at the end of the two presentations today. So you are welcomed. And I see several of you have already asked us questions. So thank you so much for all those curious brains out there. You're welcome to put a pertinent question, a relevant question into the Q&A about the presentations that you're going to watch today. We're also live streaming on YouTube. So we have a chat box there that you can also post questions to, and we'll feed those to the speakers. So I'm going to hand it back over to Jackie to introduce our first presenter today. So here we go. Thank you, Jackie.
Thanks, Lucinda. So our first guest speaker today is Jo Fox from Space Fund. So Jo is a long-time enthusiast of all things space. She's space champion for ESRO UK, that's the European Space Education Resource Office, partner and STEM communicator for Space Fund, and creator of Space Teams, an interactive website that takes you on a mission to Mars over lockdown and beyond. I'm excited to hear what Jo will be talking to us about today. So Jo, over to you.
Thank you, Jackie, and hello everybody. I'm so pleased to be here today. So this morning we're going to be looking at the similarities between Mars and Earth. So Earth and Mars similarities. So let's go to the first one. So my first thing I've noticed that are similar between Earth and Mars are that they're both rocky planets, just like Mercury and Venus as well. They're rocky planets. That means they have a solid surface, and it means that we are able to land and walk upon them. Other planets like Saturn, Jupiter, Neptune, Uranus are gas planets, and we're not able to do that. Now, they have similarities in their core. They both have crusts on the outside. And they have mantle, but we're still trying to find out more information about what actually the inside of Mars is like. Okay, Mars and Earth are both in the habitable zone, or as I like to call it, the Goldilocks zone. And it's called the Goldilocks zone because they both orbit the sun in an area that's not too hot and not too cold. So if you have a look on the diagram here, we've got Mercury and Venus. Now they're much close to the sun and they're too hot. We think they're probably too hot to, have life on it. Although recently there is discussion going on amongst scientists about the possibility of some life in the atmosphere of Venus. So we shall see about that. And then if we go back to Jupiter, Saturn, Uranus and Neptune, we think they're probably too cold to harbour life. So here's my Goldilocks porridge I've put on top here. So we've got the porridge that's just right in the habitable zone, and too hot down here and too cold in the outer areas. Okay, so the next similarity. They both orbit the sun. So let's have a look here. So we've got Earth spinning round, much closer to the sun than Mars, but they're both orbiting the sun. But you might also notice that Earth seems to be spinning around a lot quicker. And in fact, Earth, as we know, takes 365 days, which is the length of our year, to take one orbit around the sun. But Mars takes 687 Earth days to get around the sun. So really, it's about double the time it takes for Mars to get around the sun. So it's about 2 of our Earth years. Okay, Now here we're looking at the way that the planets spin on their axis. So if you have a look here, we've got all the planets spinning around. If you look down at Jupiter in the bottom left-hand corner, this is where we get the length of a day from. So when a planet spins on its axis once, that's the length of a day. Now, if you have a look at Jupiter, it's spinning around in just 9 hours, 55 minutes. And Saturn is quite similar, just 10 hours, 40 minutes. So they've got very, very sort of quick days. If you have a look at Earth, we've got 23 hours, 56 minutes. That's 24 hours. But if you have a look at Mars, it's very similar. You might note here that Mercury and Venus have got very, very long days. They look like they're hardly moving at all. But you can see that Earth and Mars are very similar. Mars's day is just about 40 minutes longer than a day on Earth. Now, you'd think that 40 minutes longer wouldn't really matter. But I had a little look at this because I thought it was quite interesting. So if you were on Mars and you were going to school on Mars and you were having to get up at 7:30 in the morning, on Monday you'd get up at 7:30 in the morning, but because the day is 40 minutes longer, on Tuesday you'd be getting up at 8:10. On Wednesday you'd get up at 8:50, Thursday 9:30, Friday have a bit more of a lie-in, 10:10, and then Saturday 10:50. Sunday 11:30, and then when you get back to Monday again, you'd be getting up at 12:10. You'd be getting up in the afternoon. So this actually is one of the things that scientists are looking at. If we went to live on Mars, although the length of the day is quite similar, it would actually make you feel a bit jet lagged the whole time. And they're thinking of ways of how we could cope with that. Now, scientists that work on Mars rovers while they're actually on Mars, like with Curiosity, for the first 90 days of the mission, all the scientists and engineers that are working on the mission actually live in Martian time. And other scientists have been studying them to see how they cope with it. Some people tend to cope better with others, but they do all say they feel constantly jet lagged. And they say those that are night owls, so people who are quite good at staying up late, tend to cope better than those that are early risers. And one of the ways they've coped with it is they've made nap rooms. And maybe this is something that scientists and astronauts that go to Mars one day might have to think about, that they'd have to take little naps in the middle of the day to cope with the change of time. Okay, next one. Okay, here we're looking at the tilt of the planets. Now, this is the tilt of the planet. If you have a look at our Earth, you can see it's tilted at 23 degrees. Now, it's that tilt that gives us our lovely seasons. So spring, summer, autumn, and winter. And if you have a look at Mars, it has a very similar tilt, just 25 degrees. So Mars also does have spring, summer, autumn, and winter. Again, if you look at some of the other planets, Mercury, Mercury and Jupiter, for example, they hardly have any tilt at all. So therefore, they don't really get the seasons. Now, the interesting thing with Mars is that Mars doesn't just have the 4 seasons like Earth. It actually has an extra layer of seasons on top. And that's because it orbits not in a circle like Earth does. It orbits in a more elliptical shape, which is like an oval that you can see here. And sometimes it's near to the sun and sometimes it's further away. And this has an effect on what goes on in the planet, just like the normal seasons as well. So it's much more complicated than the seasons we have on Earth. Okay, the size. Now, as you can see here, Mars is much smaller than the Earth. It's about half the size. And you're probably wondering, why am I saying this is a similarity? Well, obviously the size of the planet is different. It's half the size. And you see the moon is about half the size again. So the moon is about a quarter the size of the Earth. But if you were able, to go on to the next picture, if you were able to have a look at the area covered by the land mass, so not the sea, because Mars doesn't have any seas, if you just gathered together all the bits of land and put them together, it equals pretty much the same size as Mars. So if you were covering the whole of Mars, it would be similar to covering all the land on Earth. Okay, now obviously with Mars being smaller, it has a smaller mass, it does have effect on gravity, but you can walk on Mars just like you can on Earth. It's not like the gas planets that you'd fall straight through. But as you can see from this animated GIF, the gravity is much less, so you could jump much higher. And it might be interesting to think about what effect this would have on sports. Imagine going to Mars and playing basketball, or even just throwing a ball. You'd be able to jump much higher and throw much further. So it'd be a really fun place to go and play some sports. Now, the next point is temperature. Okay, so on this diagram, it might seem a little bit confusing at first. So this is Earth's temperature. This is sort of the lowest temperature that you can see on the Earth, going up to the highest temperature. So minus 88 degrees to plus 58 degrees Celsius. The average temperature being about 14 degrees, which is sort of like the temperature it is outside at the moment. But if you have a look at Mars, it goes from minus 140 degrees Celsius up until 30 degrees Celsius, with an average of minus 63 Celsius, really cold. But as you can see, there are some temperatures that they do share. And if you went to Mars, and you went to the equator, then in the daytime, it may feel similar to the temperature on Earth, depending on where you are. However, there is a big swinging difference of temperatures. Now, this graph shows some temperatures that Mars rover called Spirit took over a period of time. And it's quite interesting. So the red line at the top is showing in the sort of, midday, the temperatures, what they were like. And you can see with the different seasons. So in summer, you can see it does get much warmer than in winter. See the temperature going down here. But the crazy thing is with Mars is that the temperature really changes at night. So you can have a swing of over 100 degrees Celsius that changes from night to day. So you'd have to make sure you're really wrapped up warm on Mars. And scientists and engineers that send probes and Mars rovers to the planet, they have to make sure that all their equipment can cope with the high and the low temperature. There's also one other slight difference. You can see this chap on Mars is dressed a bit strangely. That's because the temperature on Mars can differ from the surface up until your head. So he's got shorts and sandals on here because at his feet, it's a nice, comfortable 24 degrees Celsius. But at his head, it's really cold. It's 0 degrees. So that's why he's got a woolly hat and scarf on. And the reason for this is because although it does have an atmosphere, just like Earth, its atmosphere is much thinner and the pressure is much less. So it's unable to keep the heating. Okay, the next point is that Mars has a moon, just like Earth. But in fact, not just one moon, it has 2 moons. And here they are. They're a bit strange shaped. We've got Phobos and Deimos, and they're very, very small. As we can see, this is only 22.2 kilometers across, where the moon's, I think, about 5,000. I'll have to check on that. So it has 2 moons, and as you can see, they're tiny. So this is a picture of Mars with Deimos, the smaller moon. In comparison, you can see it's absolutely tiny. And if we did the same here with Earth, you can see our moon actually is about a quarter of the size of the Earth. So there we go. Now this picture is quite interesting. So although the moons are smaller, because Mars's moons are much closer, they orbit around Mars much closer, they actually appear much bigger than the moon. So this is what the moon looks like to us compared to what Deimos and Phobos would look like. Now, another similarity is the geological features on Mars. There's lots, there's volcanoes, mountains, cliffs, all different things that look very similar to Earth. So here's an example. This is the Grand Canyon on Earth, photographed here. And this is a valley on Mars, the NAW Valley. And as you can see, they're very similar shape. And you know, we know that the Grand Canyon is caused by the Colorado River, so we make assumptions that water has traveled down this and caused this huge channel on Mars. Okay, so here's a picture of a riverbed on Earth, on the right hand side this time. So you can see lots of pebbles and things. And here is a picture that Curiosity, the Mars rover, has taken a picture of on Mars. And as you can see, very, very similar. And again, we know that this is a riverbed, and we can make presumptions that this too is a riverbed with lots of pebbles that have been slowly shaped over time by water. And here's some basalt cliffs. On the right, we have some on Earth in America, and on the left here, some on Mars. Again, very, very similar. Now, my final similarity is that Mars has self-driving vehicles on it, just like we have on Earth. So here's the ones on Earth, but here's the one that we have at the moment on Mars. This is Curiosity. It's about the size of a small car. As you can see, I've got a man here standing next to it to give you some sense of perspective. Now, because messages take anything from 3 minutes to 22 minutes to get to Mars, scientists and engineers can't control Mars rovers remotely like you might do with a remote controlled car or anything similar to that. So what they do is they allow these robots to work autonomously. So here we have a little video of Curiosity, the Mars rover. And what the scientists do on Earth is they tell Curiosity where they want Curiosity to go, and then using complicated algorithms, it is programmed to be able to look around and make judgments of which direction it should go. So if it came across a big rock, it should be able to make its way around the rock. So that's Curiosity. Now, we have another rover on its way to Mars at the moment. This is Perseverance. Now, this is a NASA Mars rover based on Curiosity. You can see it looks very similar. And it should be arriving in February next year. So do look out for that. It's very exciting. Now, there's a couple of things that are different about Perseverance that I find really exciting. The first thing is it's going to have a microphone on it. So we're going to be able to hear what it's like on Mars for the first time. And the other thing is this. Let's have a look. So here's an animation of Perseverance. And this is a little helicopter, a drone. The first time we're going to have a drone on Mars. And this drone is called Ingenuity. And again, it's autonomous, and it's going to be able to fly around and take photographs of Mars like we've never seen before. And it'll be able to take photographs of the Mars rovers as they're travelling around the planet. So again, another thing to look out for next year. And in 2022, the European Space Agency is sending their own Mars rover, and this one is called Rosalind Franklin, named after the famous scientist. And the exciting thing about Rosalind Franklin is that this rover, again, is working autonomously, just like our self-driving cars. But this rover has actually got a really special drill on it, and it's going to enable us to drill down 2 meters under the ground, looking for microbial life. And here's a little example of how it's able to do it. And the reason why it's drilling down 2 meters is it's trying to get under sort of the areas of layers of the Earth where radiation won't have got through. Okay, so that's the end of my presentation of the similarities between Mars and Earth.
That was fantastic. Joe, thank you so much for a great presentation, all those fantastic animations as well, and how exciting to see Ingenuity. And I'm so excited. It's like a really cool experiment that they're going to be doing to see, can we fly on Mars? And really, it's just going to be hopping around, recharging its batteries, hopping around. Such exciting stuff and engineering and technology that's going to be coming out on Mars. Okay, well, I thank you so much for your presentation. I'm going to go ahead and introduce our next speaker, and we're going to do a Q&A at the end. So thank you so much for those of you who've already been putting your questions in the Q&A box. You can continue to do so. Our next speaker is Anya Flood. She's a science communicator and educator who runs the Astronomical Midlands program at iLOFAR, which is a radio telescope in the Midlands in Ireland. And she's fascinated by all things science, I'm sure just like all of us, and space related, and loves finding new ways to help explain amazing things in the universe to everyone. Welcome, Anya.
Hi, thanks, Lucinda. It's brilliant to be talking to everybody about space and all things super fascinating. So like Joe was saying, there's lots of similarities between the Earth and Mars. And especially we think a long time ago, the Earth probably Mars probably looked a lot more like the Earth looks like now. But why has it changed? And what's the big difference between Earth and Mars? Why is there nobody living on Mars? So I'm going to talk about that a little bit. And to talk about that, first of all, we're going to start talking about the sun. Now, it might not be clear why, but we'll get there, trust me. So the sun obviously is super important. We all know that it gives us light and heat, and it allows life to flourish here on Earth, which is wonderful. But the sun also sends out more than just light and heat. It sends out a lot of radiation and something called the solar wind, which is this plasma. It's a stream of electrically charged particles. So it's not like the wind that blows our hair around here on Earth. It's a bit different to that. It's the stream of particles that are blasted out into space, and they can do a lot of harm. Now on Earth, we're very lucky. We're mostly protected from these particles. And that is because, so this is my model of Earth here, and we're protected. So this is Earth here in the middle. We're protected from these particles by this shield we have. It's an invisible shield, we can't see it, but it's our magnetic field that's around the Earth. It's all the way around the Earth. It's like we have a big bar magnet right in the center of the Earth, and that protects us because these particles from the sun, they can't get through this magnetic field. So they kind of just go around the Earth and pass on by, and they don't do us any harm. Now, you might have heard sometimes they do leak in. There's little gaps at the North and South Pole. So they leak in a little bit, and they cause some really cool things like the aurora or the northern lights. That's actually caused by the solar wind. And it's because of our magnetic field here on the Earth. But Mars, on the other hand, our model of Mars, you notice it's very different to Earth, doesn't have any magnetic field. So Mars doesn't have a magnetic field protecting its whole planet. So when the solar wind comes, it can cause harm. So it comes right onto the planet and it strips it away. So we think in the past, Mars had an atmosphere similar to Earth's, and that allowed for it to have things like water, like the way Joe was showing you the possibility of riverbeds on Mars in the past. So there's no flowing water there now, but there may have been when Mars had an atmosphere to keep all these things inside the planet. But because of the solar wind over time, it kind of washed away everything from the atmosphere. So Mars doesn't have an atmosphere anymore, or it has a very, very small amount of atmosphere. It's nothing like the Earth because we're protected. So because of the solar wind, because of the sun's activity, it has caused Mars to become much more barren. It kind of looks like a desert in most of the photos because there's no water there to allow plants to grow. It doesn't rain. It doesn't have the atmosphere. And also Joe mentioned the difference in temperature, that it goes very hot during the day, but then it goes really cold at night because the atmosphere doesn't trap in the heat and keep it warm because it's such a thin atmosphere. And also the difference between the temperature on the surface and even as small a distance as where your head is, if you're standing on the surface, that is because of the lack of atmosphere. So it's all been washed away by the solar wind. So the sun really influences the planets and what they're like. And because it doesn't have a magnetic field, it means that it's very, very different to Earth. And it would be very difficult to live on Mars. We're always talking about going to Mars, and people will probably go to Mars in the next while, but it would be a very different type of life there. So you wouldn't really be able to just go walking outside or sit in your garden or anything like that. There's sort of two main ways that people are thinking about living there. They'll either build these dome structures. So you'd have to live inside this dome. And if you ever went outside, you'd have to wear a spacesuit. So there's air that you can breathe, and so you don't get too damaged by the radiation. Or a good way to protect from this radiation coming from the sun would be to dig down into the ground and live in like a big cave or a tunnel or something down there. So very, very different to living on Earth, even if we do manage to go to Mars. So it's really interesting and it's a really cool thing, but it would be very different. You wouldn't really have the green areas and trees and plants. You wouldn't be able to go for a walk in the park, or there's no seas to go swimming in. There's no rivers. So it'd be very different to living on Earth. Does anybody in the audience, I think maybe you can raise your hands. Would anybody like to go to Mars? Is that something that is kind of exciting, or is it a bit scary? I think it's a bit of both, to be honest. I think it's really interesting that we can send robots there and find out lots about it, but I would have to think a long time before I decided to go to Mars. Pretty scary. But yeah, so that's basically, in a nutshell, the main differences between Mars and Earth. Joe talked to you about how it's a really similar planet. They're both solid rocky planets. Mars is a bit smaller than Earth, so my models aren't perfect. But the main difference is the magnetic field. So we're really lucky on Earth that we have a magnetic field. Other planets have magnetic fields as well, but that protects us so much from the damaging radiation coming from the sun, which has made Mars a very different place to live. So that's the end of my presentation, but I would love to answer all of the questions you have about it. And if you want to know more about the sun and how we discover these things. So Lucinda mentioned that I work with a radio telescope in Ireland, and it's part of a whole European network of radio telescopes all across Europe, including in the UK. And a lot of the things that we study are related to the sun. So we learn more about the sun and this stream and the solar wind and all the stuff coming from the sun and how they affect us here on Earth. And we can learn more about how they affect other planets as well, like Mars, using these telescopes on Earth. So there's lots of ways to learn about Mars, using telescopes on Earth and telescopes in space, and also sending robots to Mars. So we combine all the information from these things all together to understand it more.
That was fantastic, Anya. Thank you, and I appreciate that you can tell us a little bit more about ILOFAR in Ireland and what you do. We do have a lot of questions in the Q&A, so hoping Joe will join us as well. So let's get to them. Joe, are you still there? There you are. Hello. Okay. Maybe this one's for you, Anya. So someone asks, if I were an astronomer, what would my job be?
Oh, well, I guess there's lots of different answers to that. It depends on what kind of astronomer you want to be. So I work with lots of astronomers and astrophysicists, and they study lots of different things. So a lot of people who study things to do with space, if they're getting data and information from telescopes or from telescopes in space or satellites, they do a lot of computer programming. So they have to be able to program these machines to tell them what to do. And they also have to, when they get the information back from them, they have to be able to understand it. So they just get lots and lots of data, lots of information. They have to be able to turn that into like a graph or an image or make sense of it. So they use computers for that as well. So lots of writing computer programs, also trying to understand the physics of something. So if you see something unusual or that you weren't expecting to see, you have to try and understand what that means. So like I work with lots of people who are solar physicists, so they're obsessed with the sun and they study it all the time. We can also use the telescopes to look at different planets. So people who study Jupiter and learn about the magnetic fields around Jupiter. So it really depends on what you're interested in. So you might start doing one type of astronomy and then go and sort of start looking at something else that you find really interesting. So it's a huge area. Space is huge. So there's so many different things that you could learn or study. But a lot of the time you're working with other astronomers and trying to figure out how things work, like all kinds of science, and trying to make sense of the information you're getting. So you're working on computers a lot, but you're also working with people and working with instruments and building telescopes and building instruments. So really varied, lots of different ways to be an astronomer.
Can I add something in there?
Yeah.
Yeah, I also think you astronomers get to go to the most beautiful places on Earth. That's one thing I'm very jealous about, is that you get to go up lovely mountains and have beautiful views of the solar system and beyond.
Yeah, that's true. So if you have an optical telescope or telescope that's looking at visible light, it works best if it's in a place where there's not much light pollution. So no big cities or street lamps or anything in the way. So like Joe said, they tend to be in really amazing places, the tops of mountains, in deserts, in really cool places to go and see. And so lots of people travel there to work on them, but you can also work on them remotely a lot of the time. So that's the beauty of the internet and connectivity.
Yeah, I haven't yet, but I'd love to go to Chile and the Atacama Desert, and or even
Amazing
Mauna Kea,
place.
Hawaii. Just amazing. Exactly, Joe. Really good point. And thank you for your answer, Anya. Excellent. So Joe, this might be for you because you talked about Mars and its comparison to Earth. And one person asked, why is it take 10 minutes apart? Or you mentioned how there's a difference in, I guess, retrieving messages or receiving messages between Earth and Mars, and a time difference. Why is that?
Okay, well, that's basically because Mars is far away. So if you can remember the video where I was showing that Earth is orbiting the Earth closer than Mars. Now, sometimes the planets are close together. So when they go around, it's quite difficult without. I could get my video back up, maybe. So sometimes they're close together because their orbits are in the same area, and that's what's happening at the moment. That's why if you go outside on an evening that's clear of cloud, you're able to see Mars really clearly at the moment because it's in what we call opposition. It's close to us. And at that point, messages perhaps only take 3 minutes because we're closer. But at other times, Earth may have gone around the back of the sun and Mars is round this way, and we are really far away from each other, and therefore messages take a lot longer to get there. So if any of you were thinking about going to Mars, because they are saying we think the first person to step on Mars is at primary school at the moment, so that was really exciting. So if you were, then you'd only be able to communicate people with video messages, a bit like people do on Snapchat or emails or whatever, and you'd send a message and then you would get a response a little while later, but you wouldn't be able to have telephone conversations.
Excellent. Jackie, you want to go for it?
Yeah, I was just going to chip in. So there's been a few questions come through on the Q&A, which is about what you would see if you were on Mars. So we've talked about its atmosphere not being like Earth's. Would you see clouds? Would you see stars? What would you see from Mars? I guess that can go to either Anya or Joe.
Okay, well, I'll give it a go and feel free to jump in, Joe. So on Mars, yeah, you'd see the stars similar to the way you can see them here on Earth. Sorry, I just looked out my window for no reason. It's daytime. So you would see the sky, you'd see stars. They'd look a bit different to what they would on Earth because you're looking at them from a different point. But there wouldn't be much clouds because we talked about the atmosphere and how there's not as much of an atmosphere on Mars the way there is here on Earth. So you don't really get rain, and the clouds are basically rain. So you wouldn't get clouds. It does get windy sometimes, but you wouldn't get clouds or anything. So it would probably be a better view of the night sky. You wouldn't have any clouds in your way, which is a big problem sometimes in Ireland and the UK to try and look at the stars. So you would be able to see the stars. You might even be able to see Earth in the sky sometimes. So we can sometimes see Mars in the sky. Like this week, we can see Mars in the sky because, like Joe mentioned, of where it is in relation to us. So if you're on Mars, you could probably see Earth in the sky, which is a really weird thing to think of.
Yes, you can. Curiosity took a wonderful photograph, actually. If you Google it, Curiosity's photo of Earth, and it's quite mind-boggling because you see this tiny little dot in the sky, like a star, really, a very faint star. And that's another thing to think about if you were traveling to Mars, that you would be, how you'd feel being so far away from your home planet. But yes, you can see stars. It'd be interesting to know what the constellations would be like from Mars, whether they'd be different, whether Mars has a North Star. I don't know. That would be quite interesting to find out. But yes, I think sometimes it does have a few wispy clouds, but as Anya said, that there's no rain on Mars. But there are dust storms. Mars does suffer from dust storms, and it means that during that time solar panels on rovers and things don't work, and sometimes they get covered in dust because of that. But when we say a dust storm, it's not like storms we have now. The wind is quite weak, so all the dust sort of hovers in the air rather than being blown about that you might have seen in a certain Mars movie.
I wanted to mention to the teachers out there that there's free software that you can get via the internet called stellarium.org. You can go to that website and use it. You can actually position yourself on the planet Mars, looking from Mars out at the night sky and see what objects you see from Mars perspective. So that's pretty cool, and it's free to do with your students. Also wanted to mention that the daytime on Mars is sort of a pink salmon-y color. You know, where here on Earth, our sky is blue because of certain scattering of dust particles in our atmosphere. But as the sun sets, I've heard that sunset on Mars goes blue. Is that what you guys have heard? It changes color. It actually is different or opposite of what we have here on Earth. So some things to look into, but thanks, Jackie. You want to try another question?
Yeah, so following on from that, I know you mentioned the rain a little bit and the maybe being some, lack of rain and some wispy clouds. We've had a few questions as well about whether you would be able to plant trees or, grow your own food if you were up there living on Mars. What would we need to do to be able to make that happen?
Well, I know scientists are practicing for that as we speak. There are difficulties because it's not like the Earth that we have on Earth. But there are ways we can do it using hydroponics. But the main thing we need to grow plants is water. So the most important thing when we go to Mars is to make sure we go somewhere where we know there is a supply of water. Because we could take some earth with us from Earth if we wanted to, but anybody who's ever grown anything, you know that if you get some soil from the garden centre and you don't use it for a whole year, then it's not as good as it was when you bought it, and that would be a problem for going to Mars. But there are ways, and scientists are looking into it.
Great. And then something else that keeps coming up in the chat, I think people are really wanting to find some life on Mars. So as far as I know, we've not found any life yet. But is there anything that maybe you want to add to that in terms of the experiments that we're doing? I know you mentioned the Rosalind Franklin rover, which we're hoping that we'll find something. Is there anything else that we can add?
Yeah, we haven't found evidence of life on Mars yet. Now we might. Or maybe we will find evidence that there definitely isn't life on Mars, which is also a really interesting result, that we know there's definitely none. So at the moment, we just don't really know. We need to look harder. But finding definitely none is also super interesting. And it would also make it easier for us to go there because we wouldn't be interrupting any existing life. So there's just not finding life there isn't necessarily a bad thing. Both really interesting outcomes. But if we do, they're currently looking for life there, or evidence of life. So we've seen evidence that there was probably water flowing on Mars in the past, and that would be a strong indicator that there was probably life. But you've probably noticed I'm saying probably a lot because there's a lot of things we don't know for sure. And that's what makes it so interesting. Even nowadays, when we think we know so much about everything and we have such amazing equipment, we literally sent robots to other planets and we're able to do so much. We're still discovering so much. So that's what makes it always fun and interesting.
There was an interesting meteorite that was discovered in Antarctica. I think it was probably about 25 years ago. I remember it being across all the newspapers. So somebody found it. It apparently landed on Earth. So it was something hit Mars, threw up lots of rocks into the atmosphere and out into space. And unfortunately, one of these rocks headed towards Earth, burned up a bit in the atmosphere, and then landed in Antarctica. And about 14,000 years later, a human finds it, and they take it into their laboratory. And when they looked at it through their microscopes, they saw what they thought was a fossil of a tiny microbe that looks like a little worm. It's called ALH8 4001, 84,001, I think. Really exciting name, but you could Google it and you will see the picture. But again, scientists are still saying we're not sure. It could be a microbe, it couldn't be. And that's the sort of thing that Rosalind Franklin is looking for. It's looking at tiny little fossilized microbes, or what would be even more amazing would be, because it's digging so low into the ground, it might get really lucky and find an actual microbe, which would be amazing.
Brilliant. And what a catchy name as well. I like that.
It's called Allen Hills, so that's another way to remember that.
Allen Hills.
So another question that's come in through the Q&A is, why when we see pictures of Mars, we just see lots of rocks? Where are all the rocks coming from? Why is there so many?
Well, it's kind of like if you imagine Earth. So there's also some questions that I might touch on and kind of semi-answer in this answer as well. So if Earth had no magnetic field and the solar wind was going to strip everything away, strip away the atmosphere, if all the water disappeared, so it wouldn't happen instantly, but if it did happen, if all the water disappeared, then you're left with lots. So if there's no rivers or seas, what's under those? It's soil and rock and stuff. And if all the water disappeared, all the plants would die. And the people wouldn't be here anymore either. And all the plants and animals wouldn't be there. So there'd be no grass, there'd be no trees. All that would be left is rock and soil and stuff like that. Then eventually the soil would get really dusty, because if there's no water and if there's no nutrients from the plants and from everything else, it would all just basically go back to just being rock. So if you imagine that's what happened probably on Mars, that kind of explains why there's just a load of rock. And it's kind of reddish because of iron oxide, which is something we all call rust. And that's just the elements that are in the soil. So the soil there is different to the soil on Earth. So it's this dusty sort of reddish thing. So there's no trees and plants and rivers or anything. It's just all rock.
Ah, I see.
Lucinda, didn't you study geology?
Did you say me?
Yes.
Yeah, so exactly. I'm
great.
also the executive director of the Mars Society, which advocates.
Brilliant.
So, so yeah, I have maybe a biased view about humans one day putting their feet on Mars. I'm absolutely all for that, and the possibility of living on Mars. So I've been working with them for about 20 years now and doing Mars analog research in the Utah desert and in the Arctic, simulating living and working on Mars, working with ESA and NASA. To practice what it would be like for geologists, astronomers, physicists, engineers, but teachers and students, what it would be like for them to put on a suit to live on the surface of Mars and conduct field work, or how do you even live in a small 8-meter diameter space with 5 other crew members and make sure you get along and work as a team. So absolutely. But obviously, Mars is one of the first 4 planets close to the sun. And those are all, we all know, are rocky planets, right? So definitely see a lot of rocks. And unfortunately, yeah, Mars doesn't have very much of an atmosphere. It's lost a lot of its atmosphere, so it's a very dry planet. Things on the surface, are highly radiated, like Anya mentioned. So they're not going to survive, but maybe under the surface, we wonder what is underneath there. Could it be surviving because it's got this protection from the surface of Mars? And if we found liquid water, a kilometer and a half under the surface, liquid water, and perhaps maybe that's where they're all living right now. But can humans someday go there? I absolutely think so. There's going to be a lot of work to do, and I think humans absolutely have the ability and the capabilities to create the technology. And to be humanity's next step out beyond Earth is Mars, in my view. Sorry, Jackie, go ahead.
No, it's good. So we had a question. So Joe, you were showing us before Mars's moons in comparison to Mars, and Deimos is very small. Someone's asked, how big is this compared to a place in England, say?
That's a good question. I can't remember what the measurements were, but they're only a few kilometres. So it would probably be a good project for you to do, is to find out what the diameter of these moons are, and then find a town or city which has a similar diameter. And then you can get back to me, whoever asked that question.
I think that would be great.
I do have another fact about those moons, which I didn't say at the time, which I think is fab, is that Phobos has an orbit around Mars, which actually is faster than the Mars actually spins. So it actually spins around Mars faster than the planet spins on its axis. It only takes 8 hours to go around, which I thought was quite interesting.
Great. And so I know we've talked a little bit about the rovers and all of the rovers that are up there, the rovers that are due to go. How do we actually get the samples back? So once those rovers have collected them, how do we get the data back? Do we actually get the actual samples or just the data? How does it work?
I can speak to that if you'd like. The last I've heard is that the UK has actually been funded to get this, whatever instrument they're going to build to retrieve these cache samples. So as far as I've heard, the samples are going, when Perseverance, ExoMars lands, Perseverance is going to cache.
Perseverance, it is Perseverance.
So it's going to cache these samples in these little capsules and put them on the surface of Mars in a couple of different places. And then we still need to build the instrument that's going to go out there and retrieve it. So that's going to land on Mars, I guess, pick up these and somehow launch them for then either, I don't know if they're going to be a probe sent back to Earth. So it's all still kind of have to be decided and figured out. And as far as I know, the UK is going to be a part of that. I believe Airbus has been funded some money to build whatever the engineers need to build to be able to retrieve these samples. It's something that's going to happen hopefully near in the future. Go ahead, Anya.
Yeah. Can I just check, just to be clear, that there's actually no samples being brought back from Mars yet, right?
Yeah, no.
So we have all these robots on Mars, but we're still, they just analyze them and figure out what they're made of. They can't actually send them back to us yet.
Yeah, that's
exactly.
Right.
This is going to be in the future, but it's the Perseverance rover that is going to pick up samples, put them in capsules, leave them on Mars for a sample return mission. That's what I've learned. Is that?
Yes, that's right. Yeah, I think it's got about 20 capsules. And yes, it's going to leave them in locations ready for a future mission to bring them back, which is fab. And the Rosalind Franklin rover, the European Space Agency rover that's landing in 2022, that has its own laboratory inside it. So it's able to analyze everything and send back the information. And that's really what Mars rovers have been doing, and probes that don't rove around. That's what they've been doing for the last, gosh, I don't know how long that we've been sending things to Mars, but probably since the 70s.
So Joe, what you're saying is Perseverance is actually just like a big squirrel. It's going to be collecting all these things and leaving stashes around the place.
Yeah, I think it's going to be analysing stuff as well. But yeah, it's a squirrel. I like it.
What I've heard is really cool because this Perseverance rover has 23 cameras on it, which is the most cameras I think any rover has had before. So it actually has, so once the rover picks up the soil, it actually has a camera right on top of it that's going to be able to look directly at the sample before they close it up and drop it onto the surface of Mars, which does give scientists an opportunity to analyze this sample remotely, which is what we've been doing, is all this remote science.
Yeah, and from an engineering point of view, the cameras is another thing I'm very excited about, because when Curiosity landed, they made an animation of how it lands, and I think it's called something like 7 minutes of terror. Again, if you Google it, it's amazing. You see the complicated way that it landed this huge car-sized rover on the planet. It's absolutely amazing. Now, Perseverance is landing in the same way, but these cameras that you talk about, Lucinda, they're going to be filming it. So eventually we'll be able to actually see the video of something landing on Mars, which I think, and the sound, because the microphone is going to be amazing.
Yeah, Perseverance is about the size of a Mini Cooper. a Mini Cooper car. It's the same chassis that the previous rover Curiosity is built on. So there's the same size, about the size of a Mini Cooper. And NASA has tried several different ways to land these rovers on Mars, right? They first had these huge airbags and it bounced around, and then they're testing a crane method, which is what they're going to use for Perseverance again. So you're right, 7 minutes of terror. The atmosphere is thin, but still it has to survive entering Martian atmosphere, and then it has to be able to slow down enough to land this very heavy rover. If you think of landing a car on the surface of any planet, is a pretty big job.
Yeah. And I did a bit of fact finding actually about missions. I think somebody asked how many rovers have been to Mars. I'm not sure how many rovers, but over 40 missions have been sent to Mars, but 2/3 of them have ended in disaster of one way or another. They've not made it. It's a very difficult thing to do. And one of the main difficulties landing on Mars is because of the thin atmosphere. Parachutes don't work as well as they do on Earth. And that's one of the reasons why the Rosalind Franklin rover, which was actually due to launch at the same time as Perseverance, one of the reasons why they decided not to launch it and wait another 2 years was because they needed to test out the parachutes. They weren't quite sure whether they were going to work. And when something costs millions and millions of pounds to send out, you want to make sure that it's successful. And we are getting better. We're getting more successful as time goes on, aren't we?
Great. And then there's been a lot of questions about water on Mars. I know that's been a big topic lately in the news as well. But some of the questions are quite creative. So it's saying like, is there enough water on Mars as there is now for us to survive if we were to go up there? If we were to take our own, how long would it last? How long would we be able to keep it for? And if we were to fill a swimming pool on Mars, would it just stay in the swimming pool and we'd be able to swim in it? Or would it be kind of, taken off into space? So any one of those two questions that you want to answer would be great.
Well, I can speak to the production of water on Mars. The idea is engineers could possibly create these mechanisms that we wrote, these machines on Mars that could use bring a little bit of hydrogen with us. There is a bit of hydrogen there on Mars, but also grab some CO2 from the atmosphere and do this process called a saboteur process, which is where you kind of use a bit of electrolysis to break apart some of these molecules and then put them together with others, where we can liberate oxygen from CO2 perhaps, and then we can have some oxygen. And then maybe if we can combine that together with some hydrogen, well, then we have H2O, and we can really make our own water on Mars just from the elements there on the planet, just like we do here on Earth. Obviously, we have water available to us here on Earth in abundance. But on Mars, it is there, but it's put into different places around the planet that we have to actually break apart and recombine ourselves. So it's going to take a bit of work, and we obviously know there's some underground. But the difficulty with that is we've never drilled on Mars, to these depths. So can we do that? Those are all these things that we need future scientists like yourself to help us figure this out. There's lots of really exciting problems that we need solutions for. We need engineers, we need astronomers, because there's so many things to look out there in the universe. But we also need scientists and engineers to help us solve these problems and to figure these questions out. So definitely, look into becoming a scientist and engineer, because that's going to be our future.
Yeah, and future astronauts will be recycling their water, just like on the International Space Station at the moment. The astronauts go up there and they recycle their sweat and their urine, and for drinking water. I mean, it happens on the Earth naturally. All the water we're using now will be used again by humans in the future. But it's just a small version of that. I think Tim Peake said last night's wee becomes this morning's tea. It's a great quote.
Very glamorous life. But yeah, it's basically, I suppose, having enough water to live is all about recycling and reusing the water. And like Joe said, it's the same as the whole water cycle that we have on Earth that we all learn about in school. but it's just sort of in a smaller version. So it's a bit more obvious that it's being recycled in that way. It still works.
I love it. I can't wait. I know there's a few questions come in for me as well about, you know, me wanting to be an astronaut and whether I would go to Mars. And I would absolutely love to. I think that it's, well, I mean, hopefully it'll be soon, as you say, Lucinda. But I think it's probably more looking like the young people now who are tuned into this will really get to, you know, experience going up to Mars for longer periods of time. So we can all look forward to that. A question for you now, Anya, is maybe you've already answered this, but how far can our strongest telescope currently see?
Okay, that's a really tricky question. It's a great question, a really tricky one to answer, because it's sort of like you can see further and further away, but you can't see as clearly. It's like even when you're looking with your own eyes, you can see something far away, but you might just see like a line on the horizon. And then when you get closer, you can see it in more detail. So we can see really far away, but it might get a bit unclear. So I guess the example I'm going to use is the biggest telescope that we've ever built. So there's lots of different kinds of telescopes, which touches on some of the other questions, because they all look at different types of light. So really briefly, there's this whole thing called the big electromagnetic spectrum, which is basically like the visible part is a rainbow that we're all familiar with. It's got all those colors from red, orange, yellow, green, blue, and purple. And either side of the red and the purple, there's other kinds of light. We just can't see them, but we can build machines that can see them. Like the way if you get an X-ray of a broken leg or something, that's an X-ray machine that's looking at X-ray light. The telescope I work with is a radio telescope, so it looks at radio light. So it's a different type of light, but we can build machines and telescopes that can see them. So there's lots of types of telescopes. Optical, which is the visible or optical light. We've got radio, we've got X-ray telescopes, UV telescopes, infrared telescopes, gamma ray telescopes, cosmic rays telescopes. There's lots of kinds of telescopes. So as we can look at all the different types of light and understand more about the things we're looking at. But the biggest telescope in the world was an array. So it's when we use lots of different telescopes linked together with computers to act as if they're one giant big telescope. And it was a radio telescope called the Event Horizon Telescope, the EHT, and they linked together radio dishes all across the world to basically create one giant big radio dish the size of the Earth. So we couldn't actually build one the size of the Earth, but by linking them all together, it acted like it was the size of the Earth. So an eyeball the size of the Earth. And that managed to look at a black hole in the center of another galaxy. So that's pretty far away, and managed to see the event horizon or the edge of the black hole and prove what it actually looks like. So I love that. Furthest away things that we could see in detail.
I love that. I love that you can link them all up and get a bigger picture of what's out there. So a kind of follow-on question for that, which ties Mars into this. So if you went to Mars and you used a telescope, so if you could take the best telescope up there that we can possibly take to Mars on a rocket designed for that purpose, and you looked back at Earth, what would you see? So how much detail do you think we'd be able to see if we were looking back from Mars?
Well, if you just with your own eyes, you'd probably just see it like a dot. So you can actually see Mars in the sky now, as long as it's not cloudy. But it kind of just looks like a star. It's just a dot of light. Obviously, it's not glowing itself, it's reflecting light. And it's got a bit of a reddish tinge. But otherwise, you can't see any details. It's just a tiny dot like the stars look like to us. So if you had a good telescope, like if you're looking at Earth from Mars, I haven't been to Mars, so I don't know for sure. But it's probably going to be like a tiny little dot in the sky. Joe, I know you were saying Curiosity took a photograph of Earth from Mars. So maybe, I haven't seen that. Maybe you can tell us a bit more what it looks like.
Well, it just looks like a star.
You could probably see it in a bit more detail, all right.
Yeah, it just looks like a star. But I mean, I think, you know, some of the images that people can get of Mars through their telescope. So you'd probably be able to, you know, recognize it as the Earth. But I'm not an astronomer, so I don't know.
Yeah, so we can look at the planets. So when we look at Jupiter or Saturn or Mars from here on Earth, you can see details. If you have a decent telescope, and not one of the huge ones that researchers use, just one in your own garden or something, you can see like the rings around Saturn, and you can see the storms and stuff on the surface of Jupiter. And so you can see some details like that. So if you had a decent telescope on Mars, you'd probably be able to see some of our atmosphere or something on Earth. But it would be really tiny and blurry.
I was going to say that Chris Lintott actually showed a picture of Earth from Mars on our first opening night
Oh, brilliant.
Saturday, and it was just a dot in the sky. And then he, I guess he had an image of where he zoomed in, and it was basically Earth with a little lighter shadow, which was the moon, which was pretty cool. And you could Google these online to take a look at what Earth looks like from Mars. But we are at 12 o'clock. Were there any last?
Oh, wow.
Yeah, I know the time goes by so fast when you're having fun. Any last words from Joe or Anya? Thank you so much for being with us this morning.
Well, this was a lot of fun. I know we did not get through all of the questions, but it's so great that everybody's asking so many questions. And you know what? Some of them science probably doesn't have an answer to yet. So they're great questions to be asking, because we always need to keep asking questions to discover more. But some other ones, maybe you can do some investigating and figure out yourself.
Yeah, and one of the things I love about space is that it's ever changing. We're always learning new things, and you aren't expected to know everything. So some of the questions you've asked today have made me think, oh, I'm going to go away and look that up, because I don't know the answer to that. And that's the brilliant thing about space. So thank you so much for watching. I really enjoyed this morning very much. And I am also sad that we weren't able to answer all the questions.
Well, that was just so much fun. Thank you all for your contributions today. And there is more happening all over the UK to continue the celebration of National Astronomy Week. Before, I want to thank Jackie Bell, our host, my co-host today. Thank you so much for being with us and inspiring these young people to perhaps one day also go for becoming a future astronaut, or who I like to call Marsonauts, for astronauts going to Mars. But you can find out more about us at astronomyweek.org.uk. There's events going on around the UK to celebrate this week. And later tonight, we're going to continue more with Mars on Earth, learning about how these satellites and instruments that we create to learn more about our planet by looking outward towards space. And I hope to see you there. So thank you so much for joining us. If we could all wave and say goodbye.
Bye.
Bye. Thanks, everybody. It's a lot of fun.
Bye, everyone.